All right, so this has to go with creating your own discrete random table. But on your test, this is more of the questions you're going to see. So I want to make a video just to make clear of what these questions are asking. It says use the probability distribution table below to calculate the following probabilities for the number of people in the U.S. families in 2005. Let X represent the number of people in the family. What you need to remember, which is what I've been harping on, is that this bottom row, this probability row, it all adds up to 1. Okay? So you see how I'm missing one? You see how B is unknown? Well, if they all add up to 1, and I know everything but B, what you would do is just subtract everything from 1. So I'm going to say 1, and I'm going to subtract all of these from 1. Okay, and you just keep subtracting, and whatever's left over is what B is. Okay, so that'd be 0.59, subtract 0.38. I get 0.21, subtract 0.08. Don't know why I put a line there. It's not erasing, not erasing. Gonna erase, there we go. We're gonna subtract 0.08. And I get 0.13, and then subtract 0.02, and you get 0.11. So B is actually 0.11. Okay, so they all add up to 1. That is the biggest thing you need to know. Okay, next is going to be answering these questions. Anytime you see P parentheses, it's like, what is the probability of that? So this says, what is the probability that family members are less than 4? So it wants to know, what's the probability of a family having less than 4 members? Less than does not include 4. Okay, so numbers less than 4 are going to be 3, 2, 1, and 0. So guess what you do? You're going to add up all those probabilities. So you would say 0.41 plus 0.38 plus 0.11 plus 0.08, and you would get 0.98. So there's a 98% chance that families have less than 4 members. Okay? All right, the next one says, what's the probability of a family member being greater than 4? Well, is there a number greater than 4 up here on this chart? There's not. So there is a 0% chance because there's not. It's just like saying if you want to roll a die of numbers 1 through 6, what's the probability of rolling a 7? Well, it's impossible. There's not a 7 on the die. So it would be a 0 probability, okay? The next one says, what's the probability of having 2 or 5 family members? So having 2 or, well, 5 doesn't exist, so it's 0, but you still have the 0.11. So you have 0.11 plus 0, which would be 0.11, or 11%. All right, the next one, it says, so if you look, I always check first before I start working on anything, but see if there's missing anything, and it is. We're missing a y there. Okay, so we are missing a probability here. So I would actually calculate that y before I start my problem. Okay, so I'm going to say 1 minus 0.40, I get 0.60, minus 0.28, we're going to get 0.32, minus 0.05, let's see, 0.32 minus 0.05, 0.27, minus 0.10, it'll give me 0.17. Okay, so y is actually, we're going to mark it out, y is actually 0.17. Okay, so now I have all my percents. Now I can go and answer questions. Okay, all right, so it says find the probability that you'll have 1 or more sweet tart. Well, 1 or more, see how it says 1 or more, so it's including 1 here. So 1 or more is right here, so we would just add up those probabilities. We would say 0.28 plus 0.17 plus 0.05 plus 0.10, and we'd get 0.60 or 60%. Okay? All right, next one. Erase that highlight. Find the probability that you will have exactly 0. Well, exactly 0 is right here. And what's the probability of having exactly 0? 0.40 or 40%. All right, find the probability that you will have At least 3. So at least 3 means, like if I tell you you have at least 2 chances to take the test. That means no less than. So at least 3 is I want 3 or more. Okay? So I'm going to say 0.05 plus 0.10, and I get 0.15 or 15%. Okay? All right, we're going to disregard that last question. All right, but that is how you do this section. Okay, guys?